All right, so here's your review. To find this line here, as long as it's on the perpendicular bisector, and we know that because we have a 90-degree corner there and those two marks there, then we can put these two pieces equal to each other. So 2x, make that smaller, plus 11 equals 8x minus 1. So then if you subtract 2x to both sides and add 1, you get 12 equals 6x. Divide by 2, divide by 6. What am I was already giving the answer. X equals 2. Then to figure out how big it is, you put 2 back in there. So 8 times 2 minus 1, or 15. And the explanation would be that it's on the perpendicular bisector for that theorem. Okay. QP. This is now an angle bisector because of those marks that I circled. And if as long as it's on there, then these two things should be the same. So I put 6x equals 3x plus 9, and now solve for x. So subtract 3x to both sides. Okay, 3x equals 9, divide by 3, and x equals 3. And to find out how big QP is, I put 3 back into this, so 6 times 3, or 18. And again, the explanation would be what it's on the angle bisector. Then, as long as this is marked like that, that means that that is the bisector. So this would equal that. So 5x minus 4 equals 4x plus 3. Add 4 to both sides. Subtract 4 to both sides. And I get x equals 7. Then to figure out how big the angle is, because that's what it's asking you, and it's asking you for this angle. That was not smart. It's asking you for this. Oh, I forgot I was still in my crayon. There we go. It's asking for just this one. Because it says JGK. So if that's the case, 4 times 7 plus 3, or 28 plus 3, which is 31. Okay. And again, that's another angle bisector. Okay. So those are the first 3 questions again. Shove that off to the side. And let's see, where was that here? Okay. So next thing is I'm going to plot those points first. So negative 1, 2, 3, 4, 2. Where are they? Negative 4 down, 1, 2, 3, 4. Here's B. And 0, 4 would be C. So if I tried to connect the dots as best I could, so for this, remember for the circumcenter is where the three perpendicular bisectors meet. Okay? So a perpendicular bisector is going to cut the side in half and make a 90-degree corner. So when I do that, I'm going to go halfway between A and B. So if I just count, it's 1, 2, 3, 4, 5, 6 spaces. So halfway between would be 3, 2, 3. And then I make a perpendicular line. Same thing for B. 1, 2, 3, 4. So halfway is 2. And then for this one, when we're going from A to C, it's a little bit trickier, but what can happen is if you make it go with the boxes, it should work out. And so when I look at that, 1, or if we go down, it goes down 1, 2, 3 over 2, down 1, 2, 3 over 2. This is right in the center. And if it goes down 3 over 2, the opposite reciprocal will be up 2 over 3. And if I make that line come in here, should be something like that. So coordinates for that would be -2, because it went back 2 from the original, and down 1. That's what number 4 is. Okay, 5, gonna do the same thing. One, 2, 3, up 1, 2, 3, 4, 5, make a dot. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Up 1, 2, 1, 2, 3, 4, 5. There it is. Not very good when I put it off the grid there for you. Just do your best in that part. Okay, so there's that. Then again, same kind of concept. If I go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. So halfway is 4. Make that line there. 1, 2, 3, 4. Half of that's 2. Make that line coming in here. 1, 2, 3, 4. So that is also 2. So coming in here. And that quarter pair would be at 1, 2, 3, 4, 5, 6, 7, and up 1, 2, 3, 4, 5. Okay, so that's number 5. Now, as far as the in center goes, this is where some of you guys are kind of messing up on your worksheet for this. When it's an in center, that's where all the angle bisectors meet. And so that means that NQ is the same as NR, which is the same as NS. So if I want to find those, I can just set them equal to each other. So 2x plus 1 will equal 4x minus 9. So subtract 2x over, add 9. I get 10 equals 2x. Divide by 2. I get x equals 5. Then to figure out how long it is, I just put 5 into either one. Doesn't matter. You'll get the same answer regardless. So 2 times 5 plus 1 is 11. So that's how big NS is. On number 7, same type of deal. These little lines right here are the ones that they're referring to. And as long as they are on the in-center, which it says, then they are the same. So negative 3x plus 6 would equal negative 5x. So if I add that over, divide by negative 2, x equals negative 3. And then if you plug it back into either one, I'm going to do the negative 5 times negative 3. It's just faster. I get 15. So the length of NT is 15. The length of NS is 11. That's 6 and 7. Eight, same type of deal. When you see this, these are all the same. Those are called in-centers. So if I set them equal to each other, 4x minus 10 equals 3x minus 1. Subtract 3x over, add 10. I get x equals 9. And then if I plug it back in to either one of those to find NW, 3 times 9 minus 1, or 27 minus 1, or 26. So if you notice on this one, those last three, a lot of it is just setting things equal to each other. Okay? Now, so then for a centroid is a median. So remember what a median does, it goes to the opposite side and cuts it in half. So first thing we're going to do is plot those points. So -1 up 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And then over 5 and down 2. If I connect the dots as best I can. Okay. So what I mean by that is we're going to go to this opposite side and cut it in half. So if I use some slopes, 1, 2, 2, 3, 1, 2, 1, 2, 3, I'm right here in the middle. I connect the dots. That's 1. This one's going straight up and down. It goes 8 spaces, so 1, 2, 3, 4. We're going from here to that one. And then this one goes up 1, 2, 3, 4. Or 1, 2, 3, 4, 5, 6. So if I cut that in half, up 2 over 1, 2, 3. Connect them. Where is that order pair at? So when you go over 1, 2, 3, 1, 2. So that order pair is at 3, 2. Okay, same type of thing. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. I make a dot. 1, 2, 3, 4. Down 1, 2. Make a dot. 0, 1, 2, 3, 4, make a dot. looking at this, if I go down 1, 2 over 1, 2, 3, 4, cut that in half, down 1 over 2, I'm right there. Do my best to connect dots. This one's going up 1, 2, 3, 4 over 1, 2, 3, 1, 2, 3, 4. So 1, 2, 1, 2. And this one goes 1, 2, 1, 8. So up 1 over 1, 2, 3, 4. There's a dot. Now this one doesn't look like it's here, but it is. It's supposed to be right here. So it's over 1, 2, 3, 4. Down 1, 2, 3, 4. Okay, so that's finding the centroids. Okay, so I accidentally cut off the directions. It says tell whether the orthocenter is on the inside or outside, then find its coordinates. So first thing I'm going to do is I'm going to plot the points. 1, 2, 1, 2, 3, 4, 5. 0, 1. 1, 2, 1, 2, 3, 4, 5. Okay. So, just as a reminder, an orthocenter is an altitude. So an altitude is like the height, like how tall is it one side to the next. So if I connect my dots, so drawing this, I'm going to make this go a little bit thicker just so you can see it. This one's going straight down that way. To get to this other one over here, when you think of a slope being up 1, 2, 3, 4 over 1, 2. So if it was 4, 2, to make it perpendicular, you got to flip it and change the sign. So down. So where they hit right here in the middle was that inside the triangle, on it, or outside of it, it was inside of it. And the coordinates of it looks like it's at 0, 1, 2, 3, 4. Same thing for number 12. 6, 7, down. 4, 7, 1, 2, 3, 4. So when you look at this triangle, okay, hopefully you should figure that out. That's a right triangle. So if I make the altitude come from the top, it's going to be that same line there. Same thing for this one. And then this one's going to come in here and here, right here. So when is this one? It's going to be on it. And specifically, it's at 7, -4. Only time it'll be outside of it is if it's an obtuse triangle. So if you think of the different types of triangles, scalene triangles, triangles will be inside 90-degree right triangles will be on it, and obtuse triangles will be outside of it. Okay, last page. A woodworker is cutting the largest wheel possible for a triangular scrap of wood. The wheel touches each side of the triangle as shown. At what point of concurrency is the center of the circle? That would be at point B. Okay. If you look at that one, it's right there, right in the middle. And what type is that? So when you think about all the problems that we had, was it one of those? Does it look like that? Was it one of those? Don't think it was any of those. Don't think it was a centroid. Because remember, centroids just went there. I got a feeling this looks more like these. So, looks like an in-center to me. What type are they? And they're talking about these ones right here. BG, CG, and AG. Those would be angle bisectors. Which theorem can you use to prove that BGF? This for a second. There we go, so I can see it again. BGF is equal to BGE. And so if you think about back when we had those theorems, they're talking about BGF, so this little triangle here, and BEG, this little triangle there. First of all, they share the same sides. We would know that this side and this side would be the same, and they're 90-degree corners. So which theorem? We could use HL. And then the last part, find the radius. So the fact that they give you all these other things kind of starting to try to throw you off a little bit, okay? And so let me get rid of those colors that I put in there. And to blow that up a little bit further, from B to F, oops. This 3. That's from here to here. This whole thing is 10. And this little guy right there is 8. So that's what it's asking you. Okay? So, in order for us to tell, if you think about this way, put this in green. If this goes out here 3, then that's going to be 3 because of that triangle and those corresponding parts, that CPCTC thing that we had last chapter that we didn't really talk about a whole lot, but that's what it is. So that means that the radius would be 3. Okay? Then last thing, remember to do the mid-segment. Not only is it going to be parallel, but it's going to be half as big. So if this is 12, x would be 6. If I know it connects the midpoints, And if this side's 9, then so is this. Okay, so that is your review. You can use your notes packets on your test tomorrow. You'll have a test over this. I'll put in the stream how many questions and what types there are, okay? Because this video is getting kind of long. So with that, I will hopefully see you guys soon.